what I wanted to do today is talk briefly about, I don't want to spend a lot of time on slides, but I figured I'd go through a few basics and then maybe walk through some examples of existing autograders I've written, but largely try to leave time for questions. So very briefly, what I wanted to do is explain how I've used Gradescope for the last 8 years since joining URI. And what Gradescope is a tool that came out of the math department at UC Berkeley. Initially aimed at like problem sets, traditionally what you would do in a math exams or homeworks or what have you. And by 2016, they had added this feature to do auto grading, which is where I have primarily used it. I do give problem sets in my more theoretical CS classes, but I feel where this has really saved me a ton of time is on programming assignments. So a little bit about me, associate professor of computer science, and all of the undergrad courses I teach have at least some programming component, often a pretty significant one. So I teach CSC 411, which is computer organization, but really it's sort of unofficially software engineering, and students write, thousands of lines of Rust in that class. I also teach algorithms, and I teach it somewhat unorthodoxly in that your traditional undergraduate algorithms course is entirely problem sets, and I have students do some implementation work, a fair bit of implementation work. My research is more on the theory side. I run the algorithms for big data research group, but really to put all that stuff into practice, we actually have to write code. So mostly I write in Rust. That's sort of my favorite language for the last 3-4 years. Some of my coursework assignments are also in Python. I also give problem sets. I will just go and throw this out there. I do not believe in traditional exams. I never give exams. For me, assessment has to be in programming projects and problem sets. But the question is, of course, how do I assess student progress? And this comes down to three expectations around programming code that I firmly believe in. It needs to be functionally correct, as my grad school teaching mentor once said, why would you want wrong answers fast? Programs have to be correct. It has to be performant, usually, with reasonable. This doesn't mean as fast as possible, but this means sometimes as fast as possible, or sometimes just meeting certain performance requirements. And it needs to be readable, maintainable, and expressive. And that last part is often ignored, that code is meant to be read by humans. Another way to take this is where we have tools for measuring these things. Unit tests measure correctness. Does this thing actually produce the right answer? Performance benchmarks measure, performance, right? Is this thing as fast as possible or fast enough, or does it, run within certain runtime requirements? And then linters get at the human aspect here. And these are often overlooked. Some example really good tools are in the Python programming language, there is rough. Um, Actually, a grad school friend of mine is one of the co-authors of it. Um, in Rust, there is Clippy, which is part of the standard tool chain. And in R, sorry, my Markdown environment turned the um, Rust logo, or sorry, the R logo into a um, registered trademark thing, but there's linter. Um, so, the first of these is pretty easy. I think if you know how to program, you know how to write unit tests. Benchmarking may or may not be relevant depending, but I think linters are useful and important. And one of my own goals, as we always work to advance our teaching, is to incorporate linters in my autograders in going forward. So that's sort of a next year thing. So what does Gradescope do? Gradescope basically gives us the ability to automate testing of student programming projects. This saves time for us, for our TAs, allows us to spend more of that time actually helping students. It, I think, improves consistency, particularly, if you've got a fleet of TAs and they're grading different students' assignments, there can be inconsistency there. And it helps explainability, right? You lost these points because your code did not pass this precise test. Now that the assignment's over, here's the test. You can run it yourself. So what I would like to do with the rest of the time is walk through building a really simple autograder. I was going to do this sort of starting with a blank slate and writing it. I was a little worried that there might be some Zoom related issues. So what I'm going to do is walk through some code. I'm going to use Python in my grading examples. If you don't know Python, that's fine. I'll explain everything. You don't need to know Python. You don't need to use Python in Gradescope. You can you can write autograders in a variety of languages. I find Python is sort of the easiest hurdle here, even for student programming projects that are written in other languages. And finally, all of the example code that we're going to go over is on GitHub here. So, I will pull up a local version of this, but everything is publicly available on GitHub. Okay. So this is just a local checkout of the GitHub repo I mentioned. And I'm going to start with this Python example. So there are a couple of core components to any autograder on Gradescope. The first is a setup script, and this is really just the way Gradescope works is you have it's essentially using Docker under the hood. And so you assuming an Ubuntu Linux environment, you basically just have whatever needs to be installed. In this case, the basic, apt update, installing Python and Python 3. I think this is a little bit of a relic. These days you would just say Python and you get Python 3. But 8 years ago it wasn't so pretty picture. Installing a couple of tools, including Gradescope utils, which is we'll dive into in a second. And again, the pip3 version here. Again, I could trim this down to only do the just assume Python 3. The key, though, is run autograder. And what run autograder does is, in this case, I should explain what the assignment is. This is students write a program this is in my CSC 440 algorithms course. They write a program to compute the convex hull of a set of points. So if you want to visualize it, imagine sticking a bunch of pins in a corkboard and then wrapping a string around them all, right? The string would form the convex hull. So for this assignment, they need only upload one single Python file called convexhull.py. It has to be called that. They'll get errors if they, don't include such a file, etc. What I do is I copy it into a sandbox location, cd there, and just run this script, testhull.py, and redirect output to results.json. So what's all going on here? I'll show you test hull in a second, but the key is, and when I said that you could write an autograder in any programming language, all it really needs to do is present its output in a particular JSON format. So you could use whatever language you want as long as you can, produce those results. Okay, so now let's look at test hull. So this thing is this thing. So let's look here. So so for this autograder, what I do is I have a little utility called goodhull, and that includes, assuming, although probably Khalil is an exception, assuming nobody knows any computational geometry, the property of a good convex hull is that for every line segment on the hull, every other point is on the same side of that line segment. That defines what it means to be a convex hull. All right. And so I wrote a little tool called check hull that actually tells us whether for every line segment on the hull is every other point on the same side of it. Right? We can treat that as a black box. We don't really need to understand this code for the purposes of Gradescope, but that basically does the trick. We've also got generate, which can generate random point sets. So going back to test hull, what does this do? We have a class, in this case called test hull, which subclasses from unit test.testCase. It has a decorator. That's the Python term for this little thing with an at that says its weight is 5. What does that mean? It means this is a 5-point test, right? And here's another 5-point test, and here's a 10-point test. So ultimately, these will get summed up in the resulting output to, assuming a student passes every one of these, and for simplicity's sake, I cut a few out here for purposes of the presentation, but 5 points, 5 points, 10 points, 10 points, 20 points. So 20, 30, 40, 50, right? So this is worth 50 points. Typically, I also have manual grading of things like quality of code documentation, statements of invariance, things like that. So anyways, what all is going on here? Well, here's a very simple one. Test on a triangle. I set 3 points, and I call the students compute hull function, which they were required to provide in their solution. And I assert that when I call my check hull, which I just showed you, on the student hull for those points, it constitutes a valid convex hull. So, and also that it is the proper length. Got another test that's a quadrilateral. These look basically identical. And then I've got some additional ones that rely on randomly generated points. 10 random points, 1,000 random points. Is that 1 million? Yeah, 1 million random points, and so on. And basically, the way this all works is if the assertion passes, then the resulting JSON, the stuff that is ultimately output here, indicates that number of points is granted. And if the if a given test fails, then they don't get those particular points for that test. I think at this point, what I'd like to do is pause for any questions. And if in particular, Khalil or Anne-Marie, if you have any questions I can dive into here, let's do that. Otherwise, I can go on and show you another example for that works for multiple languages. So pause if there are questions. Yes. So what do students see? Give me a moment. Let me pull something up. Okay. So this is the instructor view on Gradescope, and I created this dummy course, CSC 999. And what we can do is actually fully walk through doing this. So we're starting with the instructor view, not the student view. I'm going to create an assignment, and I'm going to make this a programming assignment. And just go to next. And we're going to use the same convex hull. I will enable manual grading so that we can also see that. And have a release date of today, and a due date of tomorrow. And I'm not really going to worry about the time. You can allow late submissions. You can, there's also a way to give extensions if a student is, ill or whatever. And you can have group submissions. So if you allow students to work in groups, You can do that. Creating the rubric, you can do that before in advance, or you can do it while students or while you're going through the submissions. And I usually choose that because students always come up with novel ways to get something a little off, and I find it, useful to I'm never going to come up in advance with all of the possible ways that could go wrong. You can also enable a leaderboard. And I'm going to do this for this one, I guess. What that is if you want something, and I only use this for like 1 or 2 assignments in a semester, but if you want students to be able to anonymously, or it's up to them, they can use their real name if they want, but they can also just use a pseudonym, be able to compare results. So I often use this well, not often, I only do it a couple times in a semester, but for students to be able to say, I've got the fastest implementation of this program, or I've got and that may or may not be part of their grade at all. Often I typically do that just for fun, but students get pretty into it. So you can enable a leaderboard. So I'm going to create an assignment. Autograder points. I'll just say 50 because I think that's what I'd come up with on. There we go. All right, so we create the thing. I could add, this is the manual rubric I mentioned. We could go through and add things. I'm just going to say something silly, make this 50 points and save outline. I mentioned earlier that this is Docker based. You can make some selections around base image OS. It's going to be Linux, but it's, which flavor, version, etc. And then select an autograder. And I'm going to just upload. I'm actually going to cheat and go to not the one we just saw, but one that I know ought to work. But wrong place. So this was, sorry, like where I ought to know where that thing is. Right. Okay. And these are the same 4 files that you saw before. I already zipped them up. So, but this is basically just a zip file containing those 4 files. Upload the thing and update autograder. And this does take a minute or two. Now, what does it look like when this is all done? The student view is basically that they get they upload their solution and then they see the results of their tests. And this is something I wanted to go back to. I'm gonna switch what I'm sharing for a moment. What they see is a bunch of test results with scores. And I'm going to switch to this multi-language example, and then we'll go back to the web interface. In the multi-language example, so this is an assignment from the same course, actually, CSC 440, but where I told students they could use their choice of languages, and basically, so the setup was a little more complicated. I installed the Rust compiler. I installed a bunch of other libraries, and then I said, you can use whatever you want as long as a make file can compile it. So, let's see. So if we look at the run autograder script, right? If you recall from the other version, run autograder was a 3-liner. This one, there's a lot more to it because it's first checking, did the student write this in Rust? Did they otherwise write it using a language that, a makefile can compile? And finally, did they write it in Python? And then once all of that is done, go and, actually run the tests. Let's see, the tests here are in a test subdirectory. So this one I have a leaderboard for. So I have students can, brag about if they want. Again, they don't have to use their real names for this part. They can brag about how fast their performance is and so on. The important thing here, the reason I wanted to bring this up is visibility. You can have students be able to see the results of a given test in advance. In other words, once they've uploaded it. By default, students can upload as many times as they want. And what I found years ago when I taught Intro CS is that students would abuse this by never actually trying to compile their code locally. They just throw it at Gradescope and see if it's stuck. And this led to a lot of frustration, a lot of TA requests and so on. So what you can do is say visibility visible. So students, given okay, it takes a couple minutes to run the test, whatever, they will see, for some definition of immediately, they will see how they did on this one. And on the other hand, if we look at some of the other tests, though this one is visible, but this test is not. You'll notice there's a visibility tag before this function. There isn't one before this function. This test, they won't see the results of until the submission deadline has passed. So to keep everyone honest, it sort of tells them, hey, you get to see some of how you did and not others, not the whole thing. So it encourages them to write their own tests and be convinced of correctness. Okay, going back to, so we took a long detour from Khalil's question about what does a student see? So what a student sees is, give me a moment. This is configured. Notice it says built as of here. What I can do is test the autograder, and this basically gives me the student interface. Notice drag and drop, or I can click, and I will go to let's see. This was, well, it almost doesn't matter, right? But I think this was Convex Hull. In this case, I just need to upload a single file for this student assignment, name for leaderboard. And it says it's submitted. And you'll be notified if your grades are made available. So this part is exactly what a student would see. This solution actually intentionally is not a fully correct solution. But you can see it passed some tests, it failed some tests. And in this case, these were all visible. So a student would would see all of this. So that's basically the student view. You also get a view as the instructor of their code, and you can even do things like if you're grading for, like, say, quality of comments or something like that, you can go in here and highlight and make. You can't do it in this test view, but if this were actually a student submission, be able to say, this is an excellent choice of name for this function or something like that. You can make qualitative comments like that. So other questions? Oh, so basically, so the core, here, a couple things. Good questions. If I go to configure autograder, right? This wanted a zip file. Now, you can also mess with manual Docker configuration. I would advise against it. What that zip file has to contain is precisely, I'll show you the requirements again. Sort of the bare minimum is a setup.sh, which could be empty, but presumably you want to install some stuff, and a run autograder. And the only real requirement is that this thing ought to produce, and I'll go back and show you exactly that in a second, ought to produce exactly the results in JSON format. And I'll show you what that looks like in a second. That's why I say this, you could use any language. Fundamentally, you just need a setup script that installs whatever you need, and a run autograder. This is what is actually executed after just the student uploads their code. So switching back to that, go to manage submissions. We see my one submission, right, which didn't pass all the tests. I'm going to go to that. And the magic here, the cheat code, is debug via SSH. Only the instructor or TAs have access to this. But this will take a second. This will give me a link to SSH in. Notice they are using AWS. And I'm going to switch to a terminal window. Okay. Let's hop in here again. Okay. So I'm here. I'm sitting on the essentially on the AWS instance that's running the autograder. And you'll notice the instructions here say just run it with this command. So I'm going to copy and paste that exact command. And this is running exactly that same script that I showed you, right? So if we just cat it, right, it's just that. Now notice it redirects output to this file. And so if we simply look at this file, we get the JSON output, which is the total, the score of the student submission. So that's basically, you could, as I said, you could use any programming language, any environment, as long as it can, spit this thing out. So does that help? Yeah, and that is I think one of the bigger weaknesses. You can run it locally in a Docker instance. right? You could set up your own Docker instance and just run it and debug locally. And that is much, much faster if you're developing new tests and so on. Anybody else have any questions? So there are other approaches. They tend to, let me just stop this share because we don't need to be looking at that. So where I did both undergrad and my PhD at Tufts, there was a terrific local homegrown autograding system developed by actually by the faculty member who was my undergrad honors thesis advisor and is now a good friend and collaborator, Alva Couch. It's about 100,000 lines of Perl. And they've been using it since 94. But it's totally not portable. It totally requires a local Linux environment that all the students use, which URI doesn't have. And so in the absence of something like that, this is the best I've found. There are others, and I have no stake in Gradescope other than sort of the departmental, we're paying for Gradescope. It would be nice if other departments who find it useful, help with the cost sharing or what have you. But that's, I mean, that's minimal. EdStem, which is another platform that I have really liked for student Q&A and discussions. I find it much nicer than Brightspace. Also has introduced or is introducing some auto grading features. I have not played with them, but in theory they exist. And there are others. I used another platform, I'm blanking on the name, like 6 years ago when I taught intro, and I really did not like it. So this is the best I have found in my limited experience for, this sort of purpose. And it blends well with courses where you would also have problem sets. They have a pretty nice interface for grading problem sets and that sort of thing. Students can just scan with their phone, or upload one way or another, upload a PDF, and then you get a fairly efficient grading interface. Everyone feel free to email me if you have any questions. I am on sabbatical this fall, but I'll still reply to email. I'm not one of those people who's going to ignore email all semesters because I'm on sabbatical. So if you have thoughts, questions, if there's anything I can, do to help you, get going. Well, thanks for attending. Glad to have a little bit of an audience here. So, hope everyone has a great rest of their summer. And I think we can probably wrap up here. All right, take care.